Hello, and for today's presentation, we're going to continue our discussion on amplifier frequency response. So a quick recap, the frequency response of an amplifier refers to the frequency range in which the amplifier will operate with negligible effects from capacitors and internal capacitances. So what these capacitances does is it lowers the gain for which signal frequencies pass through. Okay. For lower frequencies, it will be affected by coupling and bypass capacitors, while for higher frequencies, they will be affected by internal capacitances and stray capacitances. So how will we view the frequency response of amplifiers? We use this graph called the Bode plot. Okay, so the Bode plot is a measure of an amplifier's frequency against its gain. So for this graph, it's the voltage gain. Voltage gain indicated by the symbol AV. So voltage gain sa y-axis, sa x-axis, it is the frequency. And notice also that the frequency is in measured in dB. No. I mean, the frequency is in a logarithmic scale. So, hindi siya linear scale na each marker or each distance or the distance from each marker is uniform ang value. So, observe from the first marker, it's from 10 hertz. Second one, so ni times 10 siya, 100, and then 1,000, and then 10,000, and so on and so forth. So the Bode plot normally is measured using a logarithmic scale for the x-axis for the frequency, and sa y-axis pwede siya directly na ratio sa voltages or ang voltage gain, or pwede gihapon in terms of dB or decibel. Okay, so how will we convert this to dB? We'll just use the formulas we've introduced last meeting. Okay, so for voltage gain, it's 20 log VO over PI. For power gain, it's just 10 log PO over PI. So sa kaning Bode plot, voltage gain ang gamit ani. Alright? So one of the most important parameters in a Bode plot are the cutoff frequencies. Okay, so where will we measure the cutoff frequencies? It is measured at -3 dB. Okay, so -3 dB for voltage gain. That would be 0.707, this one. 0.707 times the unitless voltage gain. Diba? So, draw lang tayo imaginary line here. And wherever it will hit the graph, that is the cutoff frequency. So this is for the lower end. This is for the higher end. So upper limit frequency. So this is L. This is F U. Upper limit, lower limit. So based on the two cutoff frequencies, this is where we will also measure the bandwidth. Okay, this one, bandwidth. Bandwidth is just the difference between the upper limit cutoff frequency and the lower limit cutoff frequencies. So this is the mid-range. Again, how will we define the mid-range? It is where there is no effect on the capacitance, has no effect on the signal. Mid-range frequency of an amplifier is called the bandwidth. Okay, the bandwidth of the amplifier. Bandwidth is defined by the lower and upper cutoff frequencies, cut off any frequency at which the gain has dropped by 3 dB. Okay, or there is a decrease of 3 dB. So pwede natin ma-check using calculator that this is indeed equal to, so negative 3 divided by 20 anti-log. So yeah, 0.7079 of the voltage gain, right? So cut off frequencies. So nasa slide, nakabutang mga formulas na itong paggamiton on how to calculate for these two cutoff frequencies, the lower cutoff frequency and the upper cutoff frequency. Okay. So ang gigamit na convention sa author is higher frequency. So manlambot siya itong gamiton, FH. FL and FH. Low frequency response and high frequency response. So for the low frequency response, na itulo ka capacitors kung asa ma-influence no ang low frequency response. We have 3 capacitors, the CS, CC, and CE. CS is the capacitor sa source. Yeah, connected siya sa source. CC is connected sa collector, and E is the bypass capacitor sa emitter. So the general formula for to measure the cutoff frequency, okay, is F is equal to, I think na cover na to ni or ninyo ni sa other subject like sa circuits 2, 1/2 pi RC. So this general formula will be useful to us. It's just a matter of substituting the right kind of R and the right kind of C. Okay, so the right kind of resistance and the right kind of capacitance to obtain cutoff frequencies. So mga formulas today class is naranon sa tong slide. So ato na siyang matagsa-tagsa og use later. Okay. So I believe it would be best to actually solve an example para ma-illustrate na to ang not only how to use the formulas of course, but also how to determine the frequency response. So the main objective of this example is to find the frequency response of this amplifier. So ang atong endpoint ani is something that would look like this. It's supposed to be, it should be this one, no? Again, body plot. And that. So frequency against voltage gain, unitless voltage gain. So kung asa ang voltage gain is full, no? So unaffected siya sa capacitance, so mana siyang mid-range, right? Dire AV. And kung asa siya a factor of 0.707 AV, dire kung asa siya mag-intersect manang atong cutoff frequencies, and one line na ang bandwidth. Okay, so this is low frequency, low cutoff frequency. This is the high cutoff frequency. So we could draw the body plot later as like this, or we could also draw it like this, not frequency against unit loss voltage gain, but frequency against dB gain. Okay, so yung atong kwan is yan may tabo, no? Or yung itsura sa atong frequency response po sa dB at gamiton. Frequency and gain in dB, no? So sa atong mid-range, for which unaffected ang atong signal, so the factor is multiplied by 1 lang, di ba? So a factor of 1, I convert it into dB, 1 divided by 20, anti-lag, sorry. 20 lag 0, 20 lag 1, I mean, no? So 20 lag 1 is 0, okay? So if unaffected siya, so the gain is multiplied just by just 1. So 20 log of 1 is 0 dB. So na ang 0 dB class. Of course, no? 0 dB. And where will we measure again the cutoff frequencies? Mag-drop siya 3 dB or negative 3 dB. Na din atong imaginary line. So same magyapon, no? Of course, para sa mga itsura sa frequency response. May kalahian. No? It's just a matter of perspective. No? So muna yung atong mga cutoff frequencies. So low frequency response and high frequency response. Okay. So muna yung atong main objective for this example. So erase. We're going to solve for F, L, and F, H. Frequency response, low cutoff frequency, I mean, and high cutoff frequencies. So muna itong given, no? Circuit amplifier. If you observe, pareha siya sa atong mga gipang solve previously, but we didn't mind the values for the capacitances. Atong yung gipang ignore, no? So ignore na siya before. Kana. So we only solved for the input impedance, output impedance, and gain. So this time, of course, di na negligible ang capacitances. So we have how many capacitors here? 3 external capacitors and 5, this one, internal capacitances. So asa na sa makita? So kaning CWI and CWO, these are wiring capacitances. So kung mabalik ta sa definition sa capacitance, it just means what is the stored energy due to a separation of two metal plates. And since na may wire dire sa anywhere sa circuit and also sa ground, there must be a sort of capacitance that exists here. No? Kay wire man wire man po ni dire. So na mag sort of capacitor diha sa input na side and sa output na side. Okay. So muna siya CWI and CWO. WO. Mga, hindi man necessarily imaginary capacitances, but we could measure it like somewhere over there. No? Dito nga mga points. So how about ECE, BC, CB, and CCE? Okay. So familiar ilang mga subscript. BC, these must be capacitances in between sa mga terminals. No? So capacitance between terminal BC or base collector. So na siya. So base collector. Diba? So one is CB, CBE, and CCE is here, CCE. Okay. So there exists internal device capacitances sa kaning mga regions. No? And magyapon yung mga metal plates na nag-exist sa mga terminals. No? Ilang mga pins or points of connection, no? Metal man na. And there is some sort of a semiconductor that's in between them. So dito gikan ng mga internal capacitances. So given these parameters, let's now try to solve for the lower limit cutoff frequency and upper limit of cutoff frequencies. So where will we start? Perform sa tag DC and AC analysis. No? Bakit kita sa sinagdanan sa itong gibuhat last semester? DC analysis of AC. Okay? Hindi rin lang siguro tamad. May kung kulis-kulis. RTH. RTH daw na. RTH, VTH, IE, and RE. Small RE, may mga important, right? So RTH is, dito na ako niya, hindi na ako ibutang ang formula because, kapag na mataas na. Wow. So 1 over 68 plus 1 over plus 1 over 10K. 8.72K. BTH 14 times 10 over 10 plus 68. 1.79 volts. So IE, so that one 1.79 IBRTH 0.7 IB beta is 120 plus 121 times 1,200. Solve. This is IB times 121. .86. Saan ako? Solution. BNB 1.79. Okay, correct tala ni 0.86 milliamperes ang IE. So divide na to ang 26 millivolt divided by that. $30.2 ohms. Okay, 30.2 ohms. Next, ZI, ZO, and AV. It's ZI. So if you have your formulas, how will we solve for ZI? Voltage divider. So ito sa atong summary tables, chapter 8. No. Chapter 8, chapter 5. Yeah. So voltage divider. ZI is R1, parallel R2, parallel beta RE. So R1 is 68, R2 is 10, RE is 30 times beta is 120. So 1 over 68 plus 1 over 10 plus 1 over beta is 120 times 30.2. 2.56. So nasa may nganin, 2.56 kilo ohms. ZO is RC parallel RO, but since RO is not given, assumed to be infinity or very large number, ZO is directly equal to RC, which is 5.6. Next, AV or AV and L. No load voltage gain. R is negative RC over small RE. So AV and L is equal to 6K divided by 30. Nasa mga negative 185. So namatay load, 3.3K. So we could very well solve for the AVL. AVL is equal to, formula ni. AVNL. So if available po yung mga notes of last semester, it's better nga nakapat sila ha. So this is equal to AVNL RL over RL plus 0. So AVN 285 times RL is 3.3K over 3.3K plus 5.6K. Negative 68.6. Last, naman tayo source. This is tons. So, masolve gap na to sa ABS. ABS is equal to ABL ZI. over GI plus RS. It's 56. 100 ohms, 0.1 kilo ohm at 100 ohms. Nasa mga negative 66. Suppose na correct na din sila. Kung ipang take note. This one, that one. Yung output sa itong AC analysis. Right. So, ito na to sa frequency response. Starting with FL. Or low frequency low cutoff frequency. I mean, yung mga formula natin. Matutulog ka, gamitin, no? This one, lower limit frequency, or lower limit frequency due to the source capacitor, due to the collector and capacitor, and due to the bypass capacitor. So, unan ba ito? 1 over 2 pi Rs plus Ri, where Ri is R1, R2, beta Re. Common niyo, Zi, ba? Zi. So, Zi plus Rs lang. So, solve na to. So, FL due to source capacitor. CS. 1 over 2 pi Rs, right? Rs plus Zi. CS. CS is 0.47 microfarad. At 2.66 kilo and 0.47 micro. So, approximately nasa mga 127 hertz. 127 hertz. Pwede pa na maon, no? Actually, tuluman ka buhok. So, that's only due to CS. How about due to CC? So, RO plus RL. CC. Pag RO is ZO, no? So, ZO plus RL a day. So, which na ni? FL CC 1 over 2 pi plus RL CC. $5.6K plus 3.3K. Yeah. What's CC? 0.47 micro gyapon. Hertz. Yat nakaisa pag yun. Due to the bypass capacitor. So medyo complex naman yung formula compared to the other two. So, gani ni RE. Memorize lang ni, no? RS parallel R1 parallel R2. So, isolve natin yung una. Hindi na lang solve. RS is 100 ohms. 0.1, 68, and 10. So, RS prime. So, 0.1, parallel 68, parallel 10. No? So approximately equal to RS. So RS prime is approximately equal to RS. So gyapon. 9 ohms. Divided by beta. So RE is RE. By RE. 1.2K. Okay. And 99 over 120. So I think 30 na yun, 30.2. RE is nasa mga 30.2. No? So all the day ang value ani. Sa kaning example, at least. 30.2. So F CE FL CE is equal to 1 over 2 pi RE CE 1 over 2 pi 30.2 CE is ang itong bypass capacitor 20 microfarads. Check na ako again. Zero something along on the Okay. So 263.13 hertz. Okay, so na tayo tulo ka choices. Napalo kaya kung kano ni gamit na agi. So we have 127 hertz, 38 hertz, and 263.13 hertz. 263 lang ni. Dali. No, 263 hertz. Like sa atong slides. Right, so the body plot indicates that each capacitor may have a different cutoff frequency. Okay, correct. Ito na illustrate. It is the device that has the highest lower cutoff frequency that dominates the overall frequency response of the amplifier. So the highest lower cutoff frequency. So ang highest aning tulo, kung gamiton na to na lower cutoff frequency. So which is it? So ang 263 hertz. So ato na i-conclude. Then let's because page. Ito. 37, 38, 127, 63. 263. Hertz is greater is less than 127 hertz, which is also less than 263 hertz. Therefore, lower cutoff frequency is equal to 263 hertz. Okay. Final answer. Next, for the higher cutoff frequency. So you only have two formulas for that one. Kaya doon lang man ka types of capacitors ang mag-affect. We have the internal capacitances sa input na side and the internal capacitances sa output na side. So this one, this is the formula for the input, internal capacitances. So 1 over 2 pi RC gapon. So C, now, okay, internal, tanan, summary sa, or summation of all internal capacitances. So CI, which is equal to this one. So the summation of CWI and CBE and CMI. So what is CMI? It is the Miller input capacitance. So napoy Miller capacitance ng output, no? This one, CMO. So asa na sila nato pagkuan, no? Pag measure diba? So nalamda yung formula. No? So 1 minus AB times BC. So what is Miller capacitance? So the explanation dire, Miller effect. NEPN junction can develop capacitance. Okay, we've established that. In a BJT, this capacitance becomes noticeable across base collector for BJT and gate drain for FET. So ang Miller capacitance is may exhibit across base collector or BC. CBC for BJT and CGD for FETs. So for the input nga side, this is the formula for the Miller capacitance. 1 minus AB times CF, where CF is equal to kung BJT, so to CBC. So CBC for BJT and CGD for FET. The same gapon sa Miller output capacitance. If the gain is considerably greater than 1, then MO is equal to CF, which is equal to CBC. Okay. So much for that. Given naman ito nan. RS is given, R1 is given, R2 is given, RI, which is CI. So that is RTHI. So RTHO, if RO is infinity, mawala na siya sa picture. So RTHO is RC parallel RL. No? So CF, FH, saan ako na ba? FH, sa gamit yung convention, HI, HI, 1 over 2 pi R HI CI. HI is equal to RS parallel R1 parallel R2 parallel ZI. RS is 100 ohms. R1 is 68K. R2 is 10K. ZI is 2.56K. Kasi ang answer is todo sa RS ba? Good, plus 1 over 68K, 10K. 68 and 2.56, 100. 5. Okay. Today, we'll do running 100 ohms. How about CI? CWI plus CBE minus ABC CBC. Let's see. 5 pico, 40 pico, 12 pico, and ang AV 66. 5, 40, 12 pico. 1 minus negative 66, di ba? Negative man to. 12. So CI is equal to so 849 pico farad. So I hope that's correct. So see, FHI 1 all over 2 pi 95 849 picofarad. Okay. 1.97 megahertz. I think that's correct. FHO. Frequency response output inside 1 over 2 pi RTHO CO. So ito na ang RTHO. RC parallel RL naman din eh. Itong RC 5.6 o 3.3. Zero 0.08 about CO. CWO C CE plus CMO, which is CBC or BJT. 8, 8, and 12. Okay, so HO is equal to 1 over 2 pi 2.08 K and 28 pico. .74 megahertz. Okay, so we have two answers again. 1.97 megahertz and 2.74 megahertz. So asa sa duha. So opposite na siya, no? Sa kuan. Gusto din eh. Low frequency. Sa opposite to siya sa kuan, sa low frequency. The lowest upper cutoff frequency. So kasi mas low sa duha, 1.97 megahertz. So 1.97 is less than 2.74. Therefore, kasi itong conclusion as taas, FH is equal to 1.27 megahertz. Final answer. Okay. So, na to ni siya makita karon sa body plot. So, mag-draw sa body plot. Frequency against dB. Pwede lagi di nga ni, no? Mag-general lang nga template. F AV in dB. So this is 0, -3, -6. Formality lang ng -6. So mag-draw lang tag ingani. Then -3 is the so mo kunuhay ni atong FL kaniyang atong FH, which are 263 Hertz and 1.97 megahertz. 263 Hertz and 1.97 megahertz. So bandwidth, um, 1.97 naman sa gapon kay gamay naman kay 263. So 1.97 mega minus 263. Notice ha times na dadagat to the 6 ba ning FH. But then 7 the gap approximately. And that's it. That's how to sketch and determine, that's how to sketch the body plot of the frequency response of a BJT amplifier and to calculate the lower cutoff frequency and the higher cutoff frequency. So obviously, almost the same nagyapon nga process ang i-take if we want to solve for and determine the frequency response of a FET amplifier circuit. Generally, the same lagi formulas, 1/2πRC nagyapon. If I to i-check sa slides, yep, I think almost pareha yun, no? FET din. FET. So sa high frequency man eh. No, pareha yun, no? So that's it. Okay. So if you have any questions, you can just send me a message or anything.